Okay, hi guys. Today we're doing P1. We did this in class the other day, but I didn't record it, so I'm recording it now and uploading it so anybody who missed it can see it. P1 is basically a lot of review of what we've done, but I know that we've missed a lot from last spring e-learning, so we're just starting from the basics. The first thing is, do we know what kind of numbers these are right here? What do we call these numbers that are written as fractions? Okay, we did not remember as a class either, so I wanted to review all of basically what all the real numbers are. We're going to just go through the real number table, and I'm going to do it right over here above this heart right there. So the real numbers are a big set of numbers. We use a capital fancy R to represent them. The smallest subset of them are the natural numbers. Natural numbers are counting numbers, 1, 2, 3, 4, etc. The next level includes all of those and 0, and those are the whole numbers. I'll write a little key off to the side in a second. And the next set are my, I missed a set. The represented by a fancy Z. Let me write a little nicer. It is my integers, so that's positive and negative whole numbers. -3, -2, -1, 0, 1, 2, 3, etc. Make that a little smaller because I've got one more big circle, and that is my, the Q, which stands for my rational numbers. That's what all of these are down here. Rational numbers can be represented as fractions. They are decimals that repeat over and over. They are decimals that end. They are just rational numbers that we are very familiar with and use a lot. Inside of that, we also have, or next to that, I guess, we also have irrational numbers. I guess I'll make a box over here because they still count as real numbers, but they're not connected to my rational or whole or integers or anything like that. These are my irrational numbers over here. I don't remember the little fun symbol, so my fault. And those are numbers like pi, like radical 2. Radical 2 is a decimal, but it doesn't repeat over and over. It's a new digit each time, so that counts as irrational. E is an irrational. So those have a bunch of decimal places that don't repeat, so they don't count as rational, but they do have their own category, and all of these values right here are my real numbers. The only thing is outside of this, I do have my own separate island that is my imaginary numbers, and that's all of your I's. You saw that a little bit at the end of Algebra 2. We'll spend some time on that this year in Pre-Cal as well. So in case you didn't need a refresher, N is natural numbers, or my counting numbers, 1, 2, 3. H is my whole numbers, and that's 0, 1, 2, 3, etc. Z is my integers. Ooh, I'm trying to write nicely. It's a little messy. Integers. And that's negative and positive whole numbers. And then I've got Q, which are my rationals. And we just vaguely write them as A over B. So they're fractions, A over B. Any number over any number. If you can write a number like that, it's rational. And then I wrote irrational, I's, and reals. And so all of those make up my real numbers. So I need you to know that if it's written as a fraction, it's a rational number. Okay, that being said, let's solve. Now, you can easily plug in the calculator. What I want you to do is I want you to long divide. Let's get our brain warmed up after a long summer off. So long division, I've got a negative there, so I'm going to put it out front right there. How many times does 8 go into 7? 0 times. How many times does 8 go into 7D? 8 times, I think, 64. That's 6, carry down my 0. How many times does 8 go into 60? That's 7 for 56. Minus, how many times does 8 go into 40? Oh, finally, good. A whole number, we're going to get 0 at the end. So that's it. So my answer right here is negative 0.875. All right. Feel free to pause, try the next two. I'm going to keep going and explain them really quick. If you want to listen, if you want to try it, skip ahead and just check the answers. 5 divided by 13 goes in 2 times. 10, carry the 3 down, get a 0. That's 6 minus 30 is 0. Perfect, that was easy. 2.6. Next is 11 divided by 9, so I've got 9 on the outside, 11 on the inside. Throw some zeros in there in case I need them. 9 goes into 11 one time, minus, I get 2, bring down my 0. 9 goes into 22 times, that's 18, minus, oh, I got 2 again. Oh, shoot, we're in a, like a tornado of repeating. So I'm gonna keep getting 2 no matter how many times I do it. So now that I see the pattern, I'm gonna stop and go 1.2. This is still a rational number, even though it's a decimal that goes on and on, because it has a repeating number, it has a pattern. So that's why it's still rational. Okay, now we're going to graph on number lines. So first two are inequalities. In pre-cal, whenever you graph, I want you to, am I recording this? Yes, okay, sorry, I forgot for a second. You gotta put -2 right in the middle, and we have x is greater than or equal to means that I'm going to fill in that dot. Greater than means it goes on and on forever. Let me just use a highlighter to do that. On and on forever. Awesome. Next one should also be simple. My number line this time includes 5 and it includes 6. It's a open circle on 5. That's not the color. I want a little bit more differentiation. There we go. Open circle on 5, closed circle on 6, connecting between them. Okay, those are familiar. Those are ones that we should have seen before. Next, C, D, E, and F are all a different type of notation. Do you know what type of notation it is? We call this interval notation, and I think that you maybe got a little bit of an introduction to it last year in Algebra 2, but if not, I want to make sure that we're all on the same page. I love interval notation. We use it a lot in pre-cal, so I want to make sure that we are all understanding the same thing. It always has 2 numbers in it. The first number is always the smallest number. The second number is always the biggest number. Always, always, always. Whatever's smallest goes first, whatever's biggest goes second. After that, then around it are either brackets, either 2 brackets or parentheses, 2 parentheses, or a mixture of both. The parentheses mean, or sorry, the brackets mean that it is, it is closed. It's like a greater than or less than or equal to, so it's wherever the equal to's are because it's an included point. It is included. You do a closed circle on it, closed circle, when we graph it. It's included. As opposed to that, the parentheses is not. It's going to be an open circle, and it's like less than or greater than, and it is not included. If you look back on letter B, excuse me, that we just did, 5 was not included because I had an open circle. However, 6 was included because it was a closed circle, and I could tell that by my less than and equal to's. So that's what the parentheses and the brackets are. Brackets think less than or equal to or greater than or equal to. Parentheses think less than or greater than. Okay, let's graph some of these. All right, so I have my number line. Now, I have -infinity and 5. There's no -infinity. I can't put a point here and be like, look, I've arrived at -infinity. -infinity is a concept. It's not an actual place. It's not an actual value. Instead, I am going to write 5, and then I'll just go towards wherever -infinity is. So 5, since it's a parentheses, is going to be an open circle, and then I'm going to go towards -infinity. This is the same thing as writing x is less than, or less than, just less than, sorry, less than 5. Okay, next one. I've got 2 points. I've got -2 and I have 3. Open or close on -2, closed, open or close on 3, open. Do I shade it in or do I shade out? You might be like, Ms. White, you didn't tell us. When we're in interval notation, it's always in. This is the interval. It's from this number to this number, everything in between. If we have a multiple intervals, then it's spaces between them or shading in different directions. But right now, where it's just one interval, it's everything in between, like this. All right, keep moving. 7 to infinity. So 7 is my spot. I've got a bracket at 7, so is that open or closed? Closed. And it's going towards infinity, which again, there's no spot here that's infinity. It's just a thought, it's a concept. It's going everywhere bigger than it. So I'm going everywhere to the right. Okay, last one, F. I've got -3 and +3. Open or closed on -3, open or closed on +3. Where do I shade? In the middle. Very good. 2 open circles, shade in the middle. Take a second if you need to double check your answers, make sure that you're good. If you need to rewatch those, once you understand what interval notation is, these should not be hard. So if you have if you're having trouble with interval notation, please let me know and we'll talk about it. Next, number 3, those problems say write as an inequality. So we're going to take interval notation and we're going to write it as an inequality. Okay, my numbers that are important are 5 and 7. Inequalities always have x and then less thans or greater thans or less than equals and greater than or equal to's. The parentheses and the brackets will tell me which sign I'm using, and since it's an interval, it's all going inside, so all of these should essentially be less than symbols. It's just, is it less than or equal to? Oh, sorry. The first one is less than because it's a parentheses, it's not included. The second one is a less than or equal to because it's a bracket and it is included. I have to close that circle, I have to include that point. All right, B. Technically, we don't want to use infinity in this. It's not part of my correct interval or inequality notation. What you can do is use it to set yourself up, but I want the infinity gone by the time you have your final answer. If you want to do it the same way we just did the last one, you can write, okay, infinity and 3, those are my 2 numbers that I'm using. X is in the middle. I've got a parentheses, which means less than, and I've got a bracket, which means less than or equal to. And so I just put those in the right order. Now I just told you that we can't have infinity, so what we're going to do is we're just going to erase those 2 and leave it as x is less than or equal to 3. And this is my most correct answer. Now this is a number line. It looks like I've got 6, it looks like I've got 9, it looks like x is in the middle. Those look like closed circles to me, so I'm gonna say less than or equal to, less than or equal to. We can write inequality, interval, and graphing on the number line. Those 3 things all mean the same things. They all go together. So we're practicing going from different ways to get to each one. Number 4, now it says write as an interval. So we just practiced writing as an inequality. Now I want you to write as an interval. So that means I want it to be an interval notation. Parentheses, brackets, smallest number, biggest number. So this says x is greater than 6. What's my smallest number there? 6. X is greater than 6, so I want all the numbers bigger than 6. So what's my biggest number that I'm going towards? Infinity. I'm going towards infinity. If there's no second number, it's either positive infinity or it's negative infinity. You have to decide which one it is. X is greater than, so I'm not including 6. I'm going to do parentheses. And I don't know if I mentioned this earlier, but you never, ever, ever use brackets with infinity. You always use parentheses. Why? Because bracket means a closed circle. There's no infinity on my number line, like I've said a couple times, so I can't put a closed circle at infinity. We're just going towards it. We're getting there. It's always a parentheses in that case. All right, next one, interval. This is easy. We have to write our smallest number first, 5, write our biggest number second, 10. I've got a less than, which means a parentheses. I've got a less than or equal to, which means a bracket. Cool. Okay, keep moving. And then last one says x is less than or equal to -7. Oh God, sorry. -7 is the number. Is that the biggest or the smallest? It's the biggest because I want all the numbers less than that. X is less than or equal to. So I actually want negative infinity in this case. Again, infinities always have parentheses, but my 7 this time is going to have a bracket because it's or equal to. Okay? Rewind that part if you have any more questions or you want to go over it again. I'm going to keep rolling. Next is distributive property. This is easy. Let's share. Oh, no, that's not going to be a good color. All right. Shoot your arrows, share your m. mn squared minus mq. Now I've got 3x squared y minus 6xy to the third. This one is not, I don't need to distribute, I'm gonna undistribute, I'm gonna factor it. So I have a 3 and a 6, so I've got a common factor of a 3. That would leave me essentially a 1 in here and a 2 over there. I've got x squared and I've got x, so I've got at least one x in each of them. That leaves me an x in the first term, but no x's in the second one. And last, I have a y, and then I have a y to the third. So I have at least one y in each of them. That leaves nothing in the first term, and it leaves a y squared in the second term. Let me rewrite this a little nicer. 3xy, the 1 is redundant. I don't want to see it. X minus 2y squared. Factoring, see what's in both terms, take it out. If I were to distribute this 3xy into that parentheses, now that would give me my starting point. All right, we're gonna name some properties. I'm gonna go through these and tell you what they are. If you don't remember properties, I would, I mean, you can Google search it and find a YouTube video really quickly. There's a lot of different ones, but the ones that I'm showing you here are the most important. So the first one, whenever you're doing a number times 1, that's going to give you the same number. We call that the identity. The identity property, we call it the multiplicative identity because 1 is the identity in the multiplication. If you multiply by 1, you get the same thing out. So anytime you add or multiply something and get the same thing out, then it's the identity. The next one, I've got x times y times z equals x times z times y. The only thing that changed here was what was in my parentheses. When I switched their positions, we call that the commutative property. Whenever you switch the positions, that's my commutative property. Next one looks super similar. It says x times y times z, and then it says x times y times z. I decided to regroup it. I have different things being multiplied together. When you regroup, we call that the associative property. We are reassociating the pieces together. Next is m plus 0 equals m. I added something to m and got m out again. So this is another identity. This is my additive identity if you want to be super specific, because I am defining the identity in addition. Letter E says 3 times 1/3 equals 1. Anytime you multiply two things together and get the identity, you get 1, or you add two things together and you get 0, that's what we call inverse. We did the inverse in order to get back to the identity. 7ab equals ba, guesses? Rearranged, commutative property. 7 plus -7 equals 0. When you add two things together and get back to the identity, we call that the inverse. And then last but not least, 3 plus 4 plus 5 equals 3 plus 4 plus 5. These guys are being associated, these guys are being associated, so this is the associative property because I kind of switched things up. Okay, we got 2 more concepts and then we're done with today's lesson. Simplify. We're doing these exponent problems. I'm going to give you a quick refresher of exponent rules. So over here to the side, if I am doing x to the a times x to the b, by multiplying the bases, that means I'm adding the exponents. If I'm dividing the bases, x raised to the a divided by x raised to the b, then you are minusing those exponents. If you're doing the power of it, so if I'm doing x to the a raised to the b power, then you multiply those two. If you do x to the negative a, that means that you flip it. It's the same thing as 1 over x to the a. I call this the flip, because sometimes the negative's on the bottom, so it's not 1 over that. The easiest way to think about it is just flipping it. And then last is like, if you have something really complex on the inside, I'm just going to do x over, or x to the a over x to the b, and then you have an exponent outside of that, you're distributing that inside. So it becomes x to the ac over x to the bc, and then you can simplify as needed from there. Okay, so keep in mind those rules as we do these next problems. Feel free to pause this and try a first couple and then start the video back up and see where you're at. We're only going to do, I think, maybe three or four of these for sake of time. So the first one, I have 3 over x to the second to the third. I'm going to distribute this 3 inside to everything. So I've got 3 to the third over x to the 2 times 3 will be 6. 3 to the third is 27 over x to the 6. That's it, the end. Cannot simplify that anymore. Next one. I've got 5x over 2y raised to the negative second. The thing I'm going to do first is I've got a negative exponent on the outside. I'm going to flip the inside and then square everything. So I'm going to go 2y over 5x. I flipped the inside, and then I'm going to distribute that square everywhere. 2 squared, y squared, 5 squared, x squared. And you can do that in one step. 2 squared we know is 4, y squared is y squared, 5 squared is 25, x squared is x squared. Can you simplify that? I don't think so. Keep moving. Okay, C. When you've got a big confusing problem like this, I would try and take it piece by piece. I'm going to focus on this guy first, and then I'll focus on this guy, and then I'll combine them together. So I've got 5 over 6. I cannot simplify that. Then I've got x squared and x to the third. 2 minus 3 is negative 1. That's going to leave me an x on the denominator. Then I've got y over y squared. That's going to leave me a y in the denominator. Now I'm going to look at the other fraction. 3 is my only constant, so I'm going to keep him. Then I've got x over x to the fourth. 1 minus 4 is negative 3. X to the third goes on the bottom. And then y to the fifth over y to the third. 5 minus 3 is squared. Y squared. Okay. Now I'm going to look piece by piece. You can multiply straight across and then simplify. I would rather simplify now though. If I look across the diagonals, that's across fraction lines, and I can simplify there, then that holds true as I keep going. So 5 and x to the third do not simplify, so I'm not going to worry about that. But these guys will simplify. 6xy and 3y squared. So 6 and 3 have a common factor of 3, so I'm going to take that out and get a 2 on the bottom. And then I've got a y squared and a y. I can take away 1 y from each of those. That's going to give me 5y on top. And on the bottom, I've got 2x and x to the third, which is going to be 2x to the fourth. And then square it off. All right, in each class we did a different one, D and E, and then we're going to finish that for the do now the next day. So ask a friend or try those 2 on your own and check in class. I'll put an updated key online at some point, so if you're not in class, you can at least see what we're doing, or you can follow along via Zoom. I'm going to move on to the scientific notation. The first one says 42,000. If we're moving the decimal 1, 2, 3, 4, we always move it between the first 2 digits. 4.2 times 10 to the, since it was a really big number and I moved the decimal to the left, it's going to be a positive exponent, x to the, or 10 to the fourth. Vice versa, if I have a really, really small number and I move it to the right to get between my 2 digits, I have 1.6 times, this time to the negative 1, 2, 3, 4, negative fourth. I'm going to do D last just for time's sake. When you have anything like this, C and E and D are all very similar. I want you to focus on the decimals together, and then I want you to focus on the 10 to the exponents together. We just did exponent practice, so if I'm doing 10 to the 6th times 10 to the 9th, that means I have to add my exponents together. That gives me 10 to the 15th. Now, for sake of time, I'm just going to tell you 1.5 times 7.6 is 11.4. Am I done? No. You have to move the decimal 1 more place up. Oh, that was messy, sorry. one more place up to be in between the first two digits. So I'm going to have 11 or 1.14 times. And if I move it one more spot up to the left, then I'm going to add an exponent to be 10 to the 16th. That would be my final answer. Deal with the decimals, deal with the tens to the whatever power. And last but not least, just because over the summer we forget a lot of things, if you have -4 squared, that is not the same thing as -4 squared. And that's not the same thing as that. So vice and vice versa. Be careful, you know where the negative is. If it's on the outside, square first and then do the negative. If it's on the inside, deal with the negative in the square. All right, that is today's lesson. If you need anything, please let me know. And I will see you tomorrow for the next lesson.